Possible implications majorly dependable on nanotechnology are currently under ongoing debate of scientists. It is believed that a vast range of applications can be unlocked by creating a number of new materials and devices with the help of nanotechnology. Following are the possible applications of nanotechnology that are currently under experiment: nanomedicine, nanoelectronics, energy production based on biomaterials, consumer products based on nanotechnology. Like any other technology, nanotechnology also raised some concerns and issues related to toxicity and environmental impact caused through non-material. Potential effects of nanotechnology in global economics are also a thing of concern. Speculations are also made on several doomsday scenarios that are possibly caused due to implications of nanotechnology. Due to these concerns, various advocacy groups and governments had to jump into the debate in order to decide whether a special regulation for nanotechnology is required or not. This talks about almost every factor related to the rise of nanotechnology. We will begin with describing the origin of the term of nanotechnology. Later on, all the basic fundamental concepts related to nanotechnology would be described. When starting to study about such a broad term, it is important to understand that you can never understand even easier concepts from a theory if you are not clear about origin of the concept and all the basic terms related to it. That is why we have decided to serve all the basic knowledge containing origin of the term and basic concepts in the very beginning. After covering all the fundamental concepts, all the modern findings and ongoing researches would be covered. It will definitely help you to get about an idea related to modern nanotechnology. Applications and implications of nanotechnologies are included as well. These concepts are based on ongoing debate related to nanotechnology. This is a complete package for getting a breakthrough in the broad enough term of nanotechnology. Origins of nanotechnology. In this chapter, origin terms and basic concepts of nanotechnology are covered. Compared to other scientific concepts and theories, scope of nanotechnology is comparatively limited. However, it is not going to be too simple or short for a beginner in the field. This chapter will describe all the basic concepts and fundamental findings in the field of nanotechnology. It will give you about a basic idea about what nanotechnology is all about. Consider it a quick breakthrough in the term. Nanotechnology is grown out of physics. In fact, in the beginning time of its development, it was considered as a sub-theory or branch of physics. The seed of nanotechnology was planted in 1959. In that time, a well-known physicist named Richard Feynman published his talk under the title "There's Plenty of Room at the Bottom." In his talk, he described that there was a minor yet possibility of synthesis on the basis of atom manipulation. Despite of the original concept being proposed in the year of 1959, the term nanotechnology was first time ever used in 1974 by Norio Taniguchi. However, in that period, the term is not as well known as it is in present times. K. Eric Drexler was highly influenced by concepts presented by Feynman in There is a Plenty of Room at the Bottom. In 1986, he referred to the term of nanotechnology in his book under the title Engines of Creation, The Coming Era of Nanotechnology. The original concept of nanoscale assembler was proposed in this very same book. According to this concept, atomic control can be attained in order to build a copy of itself. With such control, it was possible to build a copy of items that were based on arbitrary complexity, as described in the book. The Foresight Institute was founded by Drexler in the very same year, which provided a boost to the popularity of his book, and nanotechnology became a well-known term in that period. The Foresight Institute was dedicated to increasing public awareness and knowledge related to nanotechnology. They also attempted to find and study various implications of the term. However, Drexler is no longer affiliated with this Foresight Institute. In 1980s, convergence of Drexler's theoretical and public work triggered the emergence of nanotechnology as a field. As a consequence, a conceptual framework was built for nanotechnology and became popular in a short period of time. Prospects of attaining atomic control over matter achieved wide-scale attention thanks to many highly visible advances made in research and experiments. In 1980s, growth of nanotechnology was triggered by a duet of major breakthroughs as described below. In the year of 1981, first version of scanning tunneling microscope was invented. This unique microscope made it possible to unprecedented the visualization of atoms and bonds individually. By 1989, these scanning tunneling microscopes had become capable of manipulating atoms individually. Gerd Binning and Heinrich Roher were main faces behind the development of these scanning tunneling microscopes. They conducted their research and development at IBM Zurich Research Laboratory. In the year of 1986, both of these brilliant brains were given Nobel Prize in Physics. It is noticeable that no further research would have been possible if these two had not developed their unique scanning tunneling microscopes. It was a big achievement itself for them both in that era. In that very same year of 1986, atomic force microscope was invented by Binning, Quaid and Gerber. These brilliant inventions made 1980s golden time for the development of nanotechnology. Second major breakthrough was the discovery of fullereness in the year of 1985. Harry Kroto, Richard Smalley and Robert Curl were main faces behind this massive discovery. All of them were honored with Nobel Prize in Chemistry in the year of 1996 for their affiliated contribution in the field. It is noticeable that C60 was never being described as an initial term of nanotechnology. The term was in fact used referring subsequent work that was related to graphene tubes. Graphene tubes are also known as carbon nanotubes and bucket tubes. These tubes are suggested to be potential applications based on nanoscale electronics and devices from the same scale base. In the very beginning of 2000s, field of nanotechnology attained a bit of extra attention from science, politics and from commercial world as well. Both progress and controversies were developed due to such increased attention. Controversies related to the field of nanotechnology were emerged based on definitions and potential implications of nanotechnology. These controversies were exemplified based on the report on nanotechnology prepared by Royal Society. Feasibility of applications was also throwing challenges in the path of nanotechnology. These kinds of challenges were envisioned by molecular nanotechnology advocates. These facts were culminated in a public debate. This debate was between Drexler and Smalley twice in the year of 2001 and 2003. Emigration began in commercialization of products that were based on various advances of nanoscale technologies. Most of them tend to be limited to bulk applications of nanomaterials. Atomic control over matter is not involved in these products. Following are some examples of these products. Silver nano platform that is dedicated for using silver nanoparticles as antibacterial agent. Transparent sunscreen based on nanoparticles. Silica nanoparticles that are used in order to increase the strength of carbon fiber. Stain-resistant textiles that are based on the technology of carbon nanotubes. As a result, governments shifted their policies and invested into researches based on nanotechnologies in order to promote the field of nanotechnology. National Nanotechnology Initiative, established by US government, is a great example for such movements. This initiative was responsible for formalizing the size-based definition describing nanotechnology. It has also supported nanoscale-based researches by establishing funds for it. European Union also supported nanotechnology researches by establishing framework programs for research and technological development. Some serious attention flourished upon the field of nanotechnology in mid-2000s. Situation is still the same in modern times, or say present times. Roadmaps for nanotechnology are now being produced or emerged by many ongoing projects. These roadmaps are centered automatically on manipulating the matter precisely. Capabilities, Goals and applications of nanotechnology are also discussed by them, which include existing goals, capabilities and applications, and projected goals, capabilities and applications as well. With this chapter ends the basic overview of nanotechnology. This chapter might already have given you about an idea of what nanotechnology is all about and when it is originated, and some important event in the history of nanotechnology. In the upcoming chapter, we will be discussing some fundamental concepts of nanotechnology on which the entire term is based. With this, first chapter comes to an end. You may now definitely acquire some basic knowledge of the subject. In upcoming chapter, we will be taking it to the next level. In second chapter, we will describe some fundamental concepts that provided or acted as a base for the development of nanotechnology as an individual field. Fundamental concepts of nanotechnology. In this chapter, we are describing basic or fundamental concepts in the field of nanotechnology. We will learn about various materials and output generated in the researches of nanotechnology. Ultimately, this chapter will guide you through various objects and materials that are used in researches related to the field of nanotechnology and nanotechnological objects. Nanotechnology is a kind of engineering based on functional system that operates on molecular scale. Both current work and concepts are covered in it. These concepts and work researches tend to be more advanced. Original sense of nanotechnology is a projected ability that is applied for construction of an item from the bottom up. High-performance products can be built through such construction by using high-end techniques and tools those researchers have managed to build or develop today. 1 billionth part of a meter is 1 nanometer, that is denoted with nm. It means that 1 nanometer is equal to 10 to 9 meter. Let us have a quick comparison for a better idea of this measure. Typical carbon-carbon bond length and spaces between those atoms in a molecule are within the range of 0.12 to 0.15 nanometer. Double helix of DNA have diameter around 2 nanometers. Let us go a little bit bigger now. Bacteria of genus Mycoplasma are the smallest cellular life from present. Its longest length was noticed of around 200 nanometers. According to the definition provided by National Nanotechnology Initiative in United States, objects that fall within the scale range of 1 to 100 nanometers, the lower limit of this range is set according to the size of the atom. Atom is used as idea since atoms and molecules are used in order to build devices in nanotechnology. Here, it is noticeable that hydrogen atom is the smallest in the world. Size of a hydrogen atom is about 1/4 of 1 nanometer. More or less, the upper limit of this range tends to be arbitrary. It is the measurement at which phenomena that is not observed in large structure begins to be apparent. Such phenomena are capable of being used to make a nano device. These phenomena are responsible for making nanotechnology distinct from devices that are miniaturized versions of devices that are merely equivalent to macroscopic devices. Devices that fall under the description of microtechnology are a great example for these statements. In order to put such scale in another context, a marble's size compared to Earth is same as a nanometer compared to meter. There are two main approaches in nanotechnology. First one is bottom-up approach. In this approach, molecular components are used in order to build material and devices. These components are chemically assembled according to the principles of molecular recognition. Second approach is known as top-down approach. In his approach, large entities are used in order to construct nano-objects. Control at atomic level is not involved in this approach. Scientific foundation of nanotechnology is being constructed since last few decades. Through this period, many fields in physics are evolved too, including nanoelectronics, nanomechanics, nanophotonics, Nano Ionics, etc. Larger to smaller. A number of phenomena are developed with the decreasing size of the system. Statistical mechanics and quantum mechanics are a part of these. Quantum size effects are a great example for demonstrated. In quantum size effects, electronic properties of solids are altered. In such process, particle size goes through a great reduction. However, this effect does not apply when switching from macro to micro dimensions. However, quantum effects are intensive when maximum range of nanometer is reached. It is normally the scale of 100 nanometers, or a little bit less than that, where quantum effects are at their peak. That is why this scale is known as so-called quantum realms. Yes, quantum realm consisting thousands or more objects is nothing but a tiny scale range. Compared to macroscopic systems, a number of properties change, such as physical properties, mechanical properties, electrical properties, optical properties, etc. Following are some examples of such effects. Increment in surface area level. Altering mechanical of volume ratio. Materials' thermal and catalytic property. Diffusions and reactions at nanoscales are known as Nano Ionics. These Nano Ionics are performed with fast ion transportation of nanostructures and nanodevices. Mechanical properties of nanosystems are much of a concern in nanomechanics research. Potential risk is involved in interaction of catalytic activity of nanomaterial with biomaterial. Simple to complex. Advances in modern synthetic chemistry had made it possible to prepare small molecules to almost any possible structure. Wide varieties for chemicals are being manufactured thanks to these methods. Pharmaceuticals and commercial polymers are great examples of such chemicals. Achieving these abilities raised a question if it is possible to extend the control on higher level, on which single molecules are assembled into supramolecular assemblies. In such structures, a number of molecules are involved in a structured manner. In such approaches, concepts of molecular self-assembly and supramolecular chemistry are utilized. Such utilization is done in order to achieve a method according to which molecules automatically assemble them into a useful structure by following bottom-up approach. Here, concept of molecular recognition is important. According to this concept, molecules can be designed in a specific way according to non-covalent intermolecular forces in order to form a specific configuration or arrangement. As a direct result to this, Watson-Crick rules set of base pairing are formed. Two mutually and complementary objects or components can be designed in order to get a complex and useful object or whole there as their output. These bottom-up approaches are expected to be capable enough to configure and construct devices in parallel order. Compared to top-down methods, these methods are much cheaper. However, these methods are much likely to be overwhelmed by size and complexity with increment in desired assembly size. Complex and thermodynamic arrangements are required by most of the useful structures. These are multiple examples of molecular recognition in biology that are self-assembly based. Molecular nanotechnology. Molecular nanotechnology is often referred as molecular manufacturing. Nanoscale machines are referred as nanosystems, are molecular nanotechnology. In this field, these nanosystems are described operating on molecular scale. Strong bonds and relation exist between molecular assembler and molecular nanotechnology. Molecular assembler is a machine that is used to produce devices or structures. These devices use atom-to-atom principles and mechanosynthesis. The conventional technologies are not involved in manufacturing that is taking place in context of productive nanosystems. Moreover, these manufacturing processes are completely distinguished from such conventional technologies. Nanomaterials such as carbon nanotubes and nanoparticles are manufactured using these conventional technologies. This is it for second chapter. You now know about various nanotechnological objects and matters. However, One may definitely wonder what are practical uses of these objects and if there are any risks or harms related with using them. In upcoming chapters, we will be covering the same. Next chapter will describe how nanotechnology is useful to us in various areas practically. Applications of nanotechnology. As the title implies, this chapter will describe practical uses, or say applications of nanotechnology in real terms. It will surely help one to understand what does all the theory described in previous chapters make sense in real life. Here we go. It is estimated that over 800 manufacturer-identified nanotech products are available publicly. Such estimation was made in August 2008 by Project on Emerging Nanotechnology. It was also estimated that 3 to 4 new nanotech products are being launched in the market on a weekly basis. These entire products are listed on an online database that is publicly available for viewing. Use of the first generation or passive nanomaterials are the boundary of most of the applications. Sunscreen, cosmetics, surface coatings and multiple food products are examples of these passive nanomaterials of first generation. Gecko tape is manufactured thanks to the use of carbon allotropes. You may easily notice silver being used in food packaging, clothing and among many household appliances. Cerium oxide serves as a fuel catalyst. Sunscreen and cosmetics include some amount of zinc oxide. It is included in server coatings, paint, furniture varnishes as well. Let us move to further applications. It allows tennis balls to last longer. It can be applied to golf balls to allow them fly comparatively straight. It is used on bowling ball in order to make them eligible to last longer and maintain their hard surface. Nanotechnology is being used in trousers and socks to improve their durability. It also helps the fabric to stay cool even in summer. Do you know what medicine or cream is used in bandage? It is silver nanoparticle that is useful in healing wounds. Memory and processors used in gaming consoles and computers have become comparatively faster, powerful and more reliable thanks to nanotechnology. Nanotechnology has contributed a lot in making medical applications at general practitioners' office and home easy and cheaper. Fewer materials to manufacture and less fuel to operate are required by cars and various other automobiles thanks to the use of nanomaterials for manufacturing cars. Cleaner exhaust fume diesel engines are now being developed by scientists of the field of nanotechnologies. Platinum is serving as catalyst for diesel engine in the engines in current developments and researches. Catalyst is the component responsible for cleaning the fume particles from exhaust. In the beginning of the process, nitrogen atoms are taken by a reduction catalyst from NOx molecules with intention to free oxygen from it. As next step, hydrocarbons and carbon monoxide are oxidized by the oxidation catalyst. As an output of the process, carbon dioxide and water are formed. Both reduction catalyst and oxidation catalyst have some amount of platinum included. However, using platinum in researches or even practical application is not that efficient since platinum is super expensive and unsustainable element. DKK 15 million were invested by a Danish company named Innovationsfonden in a research related to nanotechnology. This research was dedicated to find new catalysts that can be used as a substitute of platinum in various researches of nanotechnology. In autumn 2014, several new goals were launched under this research. The goal was to increase the surface area while keeping the value of required materials as lower as possible. In these researches, it was noticed that surface energy is minimized by most of the objects. As a simple example, 2 water drops merge into one and reduce the surface area. Catalyst surface area is exposed to the exhaust fumes. It was found that efficiency of catalyst will somehow maximize if we somehow manage to maximize the surface area of that catalyst. To achieve these goals, Scientist teams involved in this research are trying to develop nanoparticles that would not merge into one another until forced to do so. Material will be saved every time surface area is optimized. Diesel engine catalysts' effectiveness would be increased with the help of such nanoparticles. It will not only decrease the cost, but also lead to cleaner exhaust fumes. The research team assures that the use of platinum would be reduced by 25% if they succeed in these researches. However, since platinum is too expensive, these 25% are not going to make much effect. It clearly indicates that there is still a lot to discover and achieve in the field of nanotechnology. Tissue engineering went through about a boost in the development. Nanotechnology played its own unique role in providing this boost. Nanotechnology is applied while designing scaffolds. In this process, researchers try to copy nanoscale features with microenvironment of a cell. It is copied directly to its differentiation that is down a suitable lineage. Here is a simple example. Scaffolds are created for several purposes, and supporting bone's growth is one of them. When developing such scaffolds, osteoclast resorption pits might be mimicked by researchers. Nanobots based on DNA origami has been successfully tested by researchers. These nanobots can carry out logic functions that help in achieving targeted drug delivery in cockroaches. Researchers have observed that computational capabilities of these nanobots are as much as Commodore 64. With several advantages, there are many things related to use of nanotechnology that raise concerns for human health and ultimately the environment of the Earth. In next chapter, we will be describing what are those concerns all about. You will be amazed to learn that the nanotubes and other nanomaterials giving us so much advantages are also harming us in some other ways. Next chapter will describe these facts more descriptively. Implications of nanotechnology. With some good comes some bad. Here are some implications of nanotechnology. These have caused noticeable damage to researchers and development of nanotechnology, since many organizations have opposed nanotechnology after learning about various harms done to the environment and human health with its applications, referred as implication here due to their side effects or risks involved with them. Nanotoxicology research suggests that human health and environment of Earth gets affected because of industrial-scale manufacturing. Because of industrial-scale manufacturing of nanomaterials and use of these nanomaterials as well. These facts are much of concern in the field of nanotechnology. Due to these reasons, it is advocated by many people and global environment associations that nanotechnology should be regulated by governments. However, there are many individuals and scientific organizations that believe scientific research and many useful and innovative developments would be restricted due to such regulation in nanotechnology. Many public health agencies are conducting researches in order to get a conclusion in the matter. These agencies, including National Institute of Occupational Safety and Health, are conducting researches in order to find how exposure of nanoparticles affects environment and ultimately human health. Unintended consequences may be delivered through some specific nanoparticles. It is observed through researches that silver nanoparticles used in socks are bacteriostatic. These particles are used in order to reduce foot odor. However, these particles are found to be released while the socks are being washed. These particles are then flushed and released into waste water stream. Critical bacteria for various ecosystems of the nature are destroyed by these particles. These particles may also harm ecosystems of farm and waste water treatment process. Center of Nanotechnology Society carries out many public deliberations on risk perception. Such deliberations are mainly carried out in United Kingdom and United States. According to these researchers, it is observed that an energy application of nanotechnology was supported by most of the participants as compared to health applications of nanotechnology. The reason behind this was predicted that there are many moral and ethical dilemmas are developed related to health applications of nanotechnology, such as high costs and availability. Many experts included David Rejewski, director of the project of Woodrow Wilson Center on Emerging Nanotechnologies, suggests that adequate oversight, risk research strategy and public engagement is crucial for successful commercialization of nanotechnology. Nanotechnology is currently regulated in the only one city in entire United States, that is Berkeley, located in California. A similar law was enacted in Cambridge, Massachusetts, however, eventually rejected. Nanotechnology possesses some insurability that is contested for both research and applications of nanotechnology. Availability of insurance is now seen as a substitute for state regulation of nanotechnology. Many people believe that such insurance would make sure that consequences of nanotechnological research and applications are not loaded as burden to whole society. Environmental and health concerns related to nanotechnology. In several areas, nanofibers are being used in a variety of products. This range of product is really wide, as it can contain a tennis racket and aircraft wings as well. It is observed that a number of pulmonary diseases can be caused due to unknowingly inhaling nanoparticles and nanofibers in the air. Fibrosis is a great example of such pulmonary diseases. Many researches were conducted on rats to practice influence of nanoparticles over human health. It was observed that nanoparticles were settled in the lung and brains of those rats who breathed it. Those nanoparticles caused noticeable increment in biomarkers of response to stress and inflammations. Skin aging was induced by these nanoparticles due to oxidative stress. These effects were more intense in hairless mice. A 2-year study over implications of nanotechnology was conducted in UCLA's School of Public Health. In this research, lab mice were made consume nanotitanium dioxide. Significant DNA and chromosome damage was observed in those lab mice. The damage was high enough to trigger off cancer, various heart diseases, neurological diseases and early aging as well. Nature Nanotechnology published a major study more recently related to matter. These studies suggested that specific forms of carbon nanotubes are as harmful as asbestos if they are inhaled in noticeable amount. It is noticeable here that carbon nanotubes were once considered as trigger to the revolution in the field of nanotechnology. An article on carbon nanotubes was prepared by Anthony Seaton and other experts. Anthony Seaton is from Institute of Occupational Medicine, located in Edinburgh of Scotland. This article stated that carbon nanotubes are certainly the materials that require to be handled with supreme care, since it is proven that many of them are dangerous enough to cause mesothelioma. Considering no specific regulation of nanomaterials from government in 2008, Paul and Lance called that engineered nanoparticles should be excused from food items. If article of a newspaper is believed to be tested and true, workers working for a paint factory are observed to develop serious lung diseases. Moreover, nanoparticles were found in lungs of those workers, says the medical reports. Regulations. As described in previous chapter, health and environmental issues related to nanotechnology are raised now and then by several environmental and health-related organizations. The debate on this now growing big as it relates to health and safety risks of humans. With these debates, demands for tighter regulation over use and experiments of nanotechnology have also own rise. Another point of these debates is that who is going to be ultimately responsible for such regulation of nanotechnology. Some of the nanotechnological products and processes related to that are currently covered by some regulatory agencies. These agencies are working in order to maintain the existing regulation of a nanotechnology. However, there are clear loopholes in the existing traditional regulation of nanotechnology. Description for regulatory was provided by Davies in the year of 2008. He described a map that included various steps and processes in order to deal with loopholes in regulation of nanotechnology. There were many holes in regulatory framework of nanotechnology which were much of a concern for stakeholders. These frameworks are helpful in accessing and controlling the risks and harms of human health related to the release of nanoparticles. On the other hand, nanotubes also attain negative attentions by being involved in several diseases as a reason. These diseases include mad cow disease, known as bovine spongiform encephalopathy, thalidomide, asbestosis, etc. Nanotubes were also of great concerns due to their involvement in genetically modified food, nuclear energy, reproductive technologies, biotechnology, etc. Dr. Andrew Maynard, Chief Science Advisor at Woodrow Wilson Center's Project on Emerging Nanotechnologies, provided a kind of unsatisfying conclusion of the matter. He tried to conclude the long-stretching debate by saying that research agencies are lacking of funds to continue researches in human health and safety. He added, due to incomplete researches, there is no proper understanding of risks to human health and safety that are associated to nanotechnology. Reacting to this conclusion, many academics have raised their voice to improve and regulate the application of the precautionary principle. While doing so, many factors were also called, such as the delay in marketing, enhancement in labeling, enhancement in safety, data development requirements. Such calls were made in relation to several known forms of nanotechnology. According to a report of the Royal Society, it was observed that nanoparticles and nanotubes are leased when nanomaterial is disposed, destructed and recycled. Keeping in concern, Royal Society suggested that manufacturers need to publish procedures describing how these materials are managed to keep the exposure minimal and reduce the effects of human health and environment. These recommendations were only applied on the manufacturers that fall under regimes of extended producer responsibility, such as regulations of end of life. According to the Center of Nanotechnology in the Society, response of the people to nanotechnology is kind of different. Depending on various public deliberations, participants are more positive towards application of nanotechnology in the field of energy production compared to healthcare applications of nanotechnology. On the basis of these responses, Center of Nanotechnology suggests that public calls demanding regulation of nanotechnology may very much be different in various technological fields in nanotechnology applications. Despite of oppositions and challenges, nanotechnology is now developed as an individual scientific theory and has managed to maintain the same status and ongoing research for decades now. Following chapter will describe some scientific tools and techniques developed in the field of nanotechnology throughout this long period of development. Tools and techniques. Here are some useful tools and techniques used and developed in the field of nanotechnology. These are developed throughout the long period of development in the field of nanotechnology. Field of nanotechnology was undergone many important modern developments. Nanotechnology was launched by two main early scanning probes that were atomic force microscope and scanning tunneling microscope, often referred as AFM and STM. There are several other types available of scanning probe microscopy. These microscopy solutions are conceptually much similar to two probes. First one is the scanning confocal microscope that was developed in the year of 1961 by Marvin Minsky. Second one was developed in 1970s, named Scanning Acoustic Microscope (SAM) by Calvin Quaid with help of his co-workers. These newer scanning probe microscopes are not limited by factors such as sound wavelength or light wavelength, giving them a comparatively higher resolution. Tip of these scanning probes are useful while manipulating non-structures. Process of manipulating non-structures is known as positional assembly. These non-manipulations can be implanted in automatic mode using feature-oriented scanning methodology. Microscopes with low scanning velocity are used in this process, making it comparatively slow. Following nanolithography are developed in the field of nanotechnology. Optical lithography, X-ray lithography, dip pen lithography, electron beam lithography, Nano imprint lithography. Lithography is a fabrication technique following top-down approach. In this process, a bunch of materials are processed in order to reduce their size at a level that matches nanoscale patterns. There is another set containing various nanotechnological techniques which are used in fabrication process of nanotubes and nanowires. These techniques are also useful in fabrication process of semiconductors. Following are some processes in which this set of techniques are applied: deep ultraviolet lithography, electron beam lithography, focused ion beam machining, nano imprint lithography, atomic layer deposition, molecular self-assembling techniques, die-block copolymers. Nanotech era was preceded thanks to precursors of these technique sets. These techniques served as extensions in various scientific advances and developments. These techniques served as supplements in developing nanotechnology. On the other hand, they were also a result of past nanotechnological researches. Nano devices are anticipated by a top-down approach. These devices need to be developed in stages using various individual components. The process is very similar to the process of developing manufactured items. Characterization of nanomaterials and synthesis of nanomaterials give much concerns to scanning probe microscopy. This comes to an end. However, we have managed to include all the required and most important terms and information. This is definitely a complete package to get a breakthrough in this broad term for beginners. Now you have an idea about what is nanotechnology all about, its basic concepts, developments, tools and techniques used in it, and all the pros or cons related to its practical applications.